Hello, welcome to my YouTube channel. So for today's video, we shall be focusing on a very vital topic in mathematics that has to do with Pascal's triangle. As an introduction, we consider the binomial theorem. The binomial theorem makes use of the Pascal's triangle in solving binomial expression. Now, the word binomial has to do with two, two expressions, either in sum or in differences. Now let us consider the expression. Let's consider the binomial expression x plus y. This has to do with bi because we have x and y raised to power 0. It equates to 1, which is the principle that states that any number or expression that is raised to power 0 is equal to 1. Now let's continue, let's assume we have x plus y raised to power 1. In this case now, both are raised to power 1, so we simply have it as x plus y. Now take note, we call these the powers, and in binomial expression, in my binomial theorem, we call it the rows, to represent either the rows or the powers. Now for the second power, let's assume we have x plus y raised to power 2. That is to say, we have it twice. So x plus y multiplying x plus y. So when we carry out this expansion, this gives us x squared. This gives us xy. This gives us yx. This gives us y squared. So that means we have x squared plus this combined to give us 2xy plus y squared. Now, considering the third power, x plus y raised to power 3, it simply means we have x plus y into 3 parts. Now recall, initially we have done for both. So we are picking these two to represent this. So it means we have x squared plus 2xy plus y squared multiplying the remaining x plus y. So let's have our expansion. Using the same principle, it means this gives us x cubed. This gives us x squared y. This gives us 2x squared y. This gives us 2xy squared. This gives us y squared x. And finally, this gives us y cubed. Now, equating, we have x cubed plus this combined to give us 3x squared y. This combined to give us 3xy squared, and then we have y cubed. Now the process could continue: x plus y raised to power 4, x plus y raised to power 5, and so on. But there is one thing you should take note of. The more the power increases, that is the number of rows, the more the problem gets complicating. So what is it in for? It simply means that there is a better and preferable means of which we can obtain this, and that is the essence of learning the Pascal's triangle. Now looking back at the initial stage when we started, we had x plus y raised to power 0. giving us 1. So let's bring down 1. Now the next one, we have x plus y, and each is having a coefficient of 1, 1. So we have 1, 1 on both sides. The next is the second power. From the result, you can see the coefficient of x squared is 1. The coefficient of xy is 2. The coefficient of y squared is 1, an invisible 1 here. Now looking at the third power, from the result, you can see the coefficient of x cubed is 1. The coefficient of x squared y is 3. The coefficient of xy squared is 3. And the coefficient of y cubed is 1. Now, there are values that are attached to each of these as we progress down the rows. But how do we obtain these values? So in the next video, I'll be taking you through how to generate the Pascal's triangle in order to obtain the coefficients that would help you in solving complex problems that involves higher powers. So click the link above the video